right, IM2 classes. Today, we are going to apply what we learned yesterday about transforming graphs, functions, to a specific function, in this case, the absolute value function. So just a quick reminder, the absolute value, remember the absolute value of x would be the distance from zero. It's distance from zero. There's more to it when we solve, but that's not what we're doing today. We're just graphing it. So the distance from zero, so that means if we did the absolute value of something like 2, that's equal to 2, because 2 has a distance of 2 from 0. But then if you have the absolute value of -2, that is also equal to 2, because -2's distance from 0 is 2. Right? So distance is always positive. So that's why when we take the absolute value of something, it is always positive. So let's look at a graph of this. I'm going to go ahead and just graph this first, and we'll fill out all this stuff. When x is -2, if we do the absolute value of -2, we get a +2. Absolute value of -1 is +1. Absolute value of 0 is 0. Absolute value of 1 is 1. And then absolute value of 2 is 2. So we're just taking the absolute value of all the x values to get our y. And then here are x, y coordinates that we're going to plot. So -2, +2. So that's the left 2, up 2. -1, +1. That's left 1, up 1. 0, 0. 1, 1 is to the right 1, up 1. And then 2, 2 is right 2, up 2. So if you notice, we get all positive y values, and we get this nice V shape. So here is the basic absolute value function. We write it for the transformation function, the transformations that we did yesterday, where we have a. Remember, if a, they'll stretch it, or flip it. We have the absolute value of x minus h. When we add or subtract inside the absolute value function, that's going to shift it left and right. And then plus k on the outside. So when we transform this function, this is the vertical shift, up or down. So when we transform this function, we're just going to do what we did yesterday with those. Important point is at the bottom right there. The important point, 0, 0. That's going to be the easiest one to shift on some of these. The generic shape, obviously it's a V shape. The domain, so if you remember, domain is possible x values. We can use any x value we want. So I'm going to write this as an equality. We can use any x value we want in the domain this function. So it's going to go anything from -infinity to +infinity. X can be any of those. The range are the y values. If you notice, we don't get any negative y values. So the range is just positive numbers. Let's write that as an inequality. Y has to be greater than or equal to 0. You know what? Or I'm going to write this the other way, because in my brain, it makes more sense, because it's 0, the y is bigger than everything. Oh, no, this is why, because I still need to write it as a range. It can be anything from 0 to +infinity. That's why it's looking weird in my brain. So this means x can be any value you can put in. There's nothing undefined for the x's. The y's we're only going to get out positive y values for this general shape. So what we want to do, we are going to transform this function. What I'm going to do is real quick put in the parent function that we just graphed on these, and that's going to make this easier. I would recommend sketching out the parent function, putting in some dotted lines. That's just going to make it much easier. For this first function, we have x minus 4. It is inside the function. So that is a vertical, or excuse me, that's horizontal shift. And because it's horizontal, it's going to be opposite of what we think. All right, so minus 4, we would think it'd be to the left, but this one's actually going to be to the right 4. All right, so every point moves to the right. 1, 2, 3, 4. 1, and actually I know what the shape is going to be. So if you just move that important point, and then you can kind of place the other points around it, that works too. Or if you need to count from every point, that's also fine. But this is the general. There we go. All right. Next one. Put in my dotted lines to show the original parent function. We are transforming. So it's going to be plus 2. That's going to be a vertical shift up 2. It's outside the function there. So each point goes up 1, 2. And then I can put in the rest of my v points. If you need to count from each point, that's fine. But if you have the general shape, it's also fine. There we go. Next one. So here we have 2. So actually, let me put in my parent function, sketch that v in real quick. Those points. It's nice that this one's nice and easy to put in quickly. And then the shift, that's minus 4 plus 2. Oh, that's just going to combine everything we just did. So minus 4 plus 2. So minus 4 is going to be a shift to the right 4 and then up 2. Inside is horizontal and it's opposite. This one is vertical. That's what you think. So each point is going to go to the right. 1, 2, 3, 4, and then up 2. Plot your point. And then put in the other points. If you need to count from each point, you can. Again, I like the absolute value function just because it makes a nice v and it's easy to put in the function around it. This next one, point, just quickly put in the parent function. So I'm going to shift that one. Again, that's going to be a shift left 1. Remember, it's opposite what you think. So plus 1 is going to be the left 1, and then down 2. So left 1, down 2. And then I can put in the other points around it. All right. So here we get some a little bit. I'm not going to do all these. I'm going to do this one here because it's going to be there's the most in that one. But first, especially on this one, because we're doing more than one transformation, it's going to be helpful to put in the parent function. All right, so this one actually has 3, or yeah, 3, but we're just going to do it in 2 steps. The negative here, this first one, that's going to flip it. And then the minus 3, that's going to be a shift to the right 3, up 4. And so you kind of want to go in order of operations here. If the things are getting multiplied, it's easier to do those first and then shift. So I'm going to take this in 2 steps. I'm going to flip this and I'm going to put these points in red. So each of these points gets flipped over the x-axis. So this point is 2 above the x-axis, so it goes 2 below. I'm actually going to plot these in red. So 2 below, this one's 1 above, so 1 below. This one's on the x-axis, so our transformed one is stays on the x-axis, not what I wanted to do. This one's 1 above the x, so the flip point goes 1 below. This one's 2 above, so the flip point goes 2 below. Dotted line. All right. Next, what I'm going to do is then the shift. I'm going to shift each of these points, not the original ones. I'm going to shift the red ones. So you flip it and then you shift. So we're doing the transformation in 2 steps. So everything's going to go to the right 3, 1, 2, 3, and then up 4, 1, 2, 3, 4. All right. And then if you need to count 1, 2, 3, 1, 2, 3, 4, you can do that, or just remember it's going to make that V upside down. It's just getting flipped over. And so here I'm going to connect these with a solid line to show that this is the final transformation. Everything is done. So our line in green, our graph in green, is the final transformation with the reflection and the shift. All right. So let's do a stretch now. It doesn't really matter. We'll just go ahead and do number 8 because there's more going on with that one. So again, this one's going to be helpful to put the put in the parent function. And actually, with the stretch, the parent function isn't as necessary. So what's going on? What we did yesterday with the stretch, so this 3 is a stretch by a factor of 3. We would look at how far away each point is from the x-axis. So this is 2 away. We would multiply that distance by our stretch factor. So 2 times 3 would be 6. The net new point would be have a distance of 6. What's nice about the absolute value is you can just use this. You can interpret it as a slope. All right. So I'm going to say the slope of our new line is going to be 3 over 1. Right. So this point stays here. And then I'm going to do up 3 to the right 1. So up 1, 2, 3, right 1. This, and then from this point again, I'm going to do the same thing, up 1, 2, 3 to the right 1. And then it's going to be a mirror image on the other side, right? And so if you look, so this point here, our original parent function, the black point, has a distance of 1 away. When we stretched it using slope, 1 times 3 is 3, so the new point is 3 away. All right. This one is 2 above the x-axis. We stretched it using a slope of 3. So we multiply 2 times 3, that's now 6 above. All right. So here is the stretch. And then I'm going to shift -2, that's right 2. And then -4 is down 4. So each point's going to go right 2, 1, 2, down 1, 2, 3, 4. And you can do that with each point. 1, 2, 1, 2, 3, 4. Or you can just remember the line's going to have a slope of 3, so it's going to go up 1, 2, 3 right here. Might be easier to count for some people. But then here, it's going to be a mirror image over here. So it's going to look like that. And then I'm going to connect these with a solid line to show that's the final transformation. So I did the stretch and then the shift. Right. Great. Let's combine everything. Why not? So here, parent function. Put in the parent function. guess I could have done the other one, but whatever. All right. So there's a lot going on here. There is here the -3, the negative flips it. We're multiplying by 3, so that's going to stretch it. And then the -4 plus 2 is going to shift it to the right 4 and then up 2. So first thing I'm going to do is the flip and the stretch. And I'm actually going to do that as, think of that as a slope. So the slope is going to be -3. Remember, slope is easier as a fraction. So I'm going to do the slope in the positive direction. So I'm going to go down 3, right 1. So to plot the next point, down 1, 2, 3, right 1. Plot the next point, down 1, 2, 3, right 1. And then I get a mirror image. And then on each of those points, I'm going to shift right 4 up 2. Right, 1, 2, 3, 4, up 2. 1, 2, 3, 4, up 2. 1, 2, 3, 4, up 2. And I can plot the other points just like that. So there we go. So I did the flip and the stretch by using that as a slope, and then I shifted them, each of the points, right 4 up 2. All right. So next, what you're going to be doing is just identifying the different transformations. This should be pretty easy. You just need to write out what it is. So this -2 is outside the parentheses. So that's a vertical shift. That's going to be down 2. I'm just going to do these odd ones. The +1 is inside the parentheses, so that's going to be right 1, down 4. The negative is going to flip it. The +1, that's going to be left 1. And +3 is up 3. +3 on the outside. The 2 is going to be a stretch. I'm not going to say it's a factor, whatever. It doesn't matter. And then it's going to be a shift up 1. The negative here, that's going to be a flip. The 3 on the outside, this 3 stretches it. The +3 on the inside of the absolute value, that's a horizontal shift. That's going to be left 3. +1 on the outside is a vertical shift. That's going to be up. And there is that. We rolled through those. Here you actually have to write out the function. All right, so we're going to have we're going to use function notation. F of x is equal to absolute value. Put in x. The left 3, that means it's going to be +3 inside the absolute value. Remember, it's opposite there. And then up 7 is +7. The outside of the absolute value. That's what we do. So f of x reflects. That's the same thing as saying flip. So it's going to be a negative in the front. I have the absolute value. Right 9 is going to be a +9 inside the absolute value. So again, horizontals are added, subtracted inside, and it's opposite. And then vertical transformations are up and down. Let's skip to number 4. F of x, people will see this fraction, the vertical shrink of 1/6. The shrink just means that's the multiplier out front. So just put a 1/6 out front. And then it also reflects, so it needs to be a -1/6. And then absolute value, there's no vertical stretch, so the x is inside the absolute value by itself. Excuse me, there's no horizontal. And then down 2 would be a -2. Let's skip down to number 6. A lot going on there. So left 5/3, up 7/12, vertical stretch of 4/3. So the stretch, that's the multiplier that goes in front. Absolute value left 5/3. So it's going to be +5/3. And then up 7/12, so that'll be +7/12 on the outside. And let's just do one more. I'm going to skip down to 10. So I have a vertical stretch, so I have a multiplier of 5 out in front. Down 6, that's going to be on the outside, so that's -6 outside of the parentheses. Right 4, so again, it's opposite of what you think, so that's going to be -4 on the inside. And that is all there is to that, and I think we are done. Yeah, that's it for today. We'll see you guys next time.